So in this video, we have a projectile problem. A ball is projected from the ground. So that means being projected means it being thrown or it's being shot from the ground level. The trajectory of the ball, so the trajectory is the actual shape that it traces out. Okay, so the equation of that shape can be modelled using this equation, this quadratic. Y equals 8.2x take away 0.4x squared. So before we actually get into any of the questions, let's just visualise what that's going to look like. So we're going to have a quadratic curve, and because we've got a minus in front of the x squared, that makes it a sad-faced parabola. There's no plus c on the end, so that means it goes through the origin. So it's going through the origin, it is projected from there, it's going to be a sad face parabola, and it's going to look something like that. So part A, the greatest height the ball reaches. So that is this point here. Now parabolas, remember, have the feature of being symmetric. Okay, there are multiple ways of getting to the coordinates of that point. Okay, so if you're immediately thinking I could find the turning point using differentiation, then yes, you could use that. Okay, differentiation isn't part of the GCSE maths specification, so I won't go through that as a method. Alternatively, we could use completing the square. Completing the square with this is a little bit nasty, so I think we'll leave that one out as well. So the third method is to use the symmetry to the point where actually I could work out that point there, okay, by looking at solving this quadratic equation, because that point is where the y is 0, because it's hitting the x-axis there. So if we consider 0 equals 8.2x take away 0.4x squared. Yes, you could use the quadratic formula here, but actually we could factorise this. Okay, there are two terms with a factor, okay, of x. So if we factor out the x, we would have 8.2 and then take away 0.4 times x, because x times that will get me the x squared. So either the x is 0, but I'm not interested in that because that's that point there, or this bracket is 0. So that means I need to solve this equation. So if I add 0.4x to both sides of my equation, I will get this, and then divide both sides by 0.4. Let's use a calculator for that, shall we? So 8.2 divided by 0.4 is 20.5. So this point here is 20.5. So actually what I've done is I've answered part B. The horizontal distance the ball reaches when it hits the ground will be 20.5, and let's assume that we're in meters. Or let's not assume that we're in meters, but we could be in meters. 20.5. Okay, so we still need to answer the greatest height the ball reaches. Well, that's going to be at the halfway point of this curve. So half of 20.5 is 10.25. So what I need to do is I need to substitute 10.25 into the equation of the parabola, and then I can read off the value on the y-axis. So substitute 10.25 into this. So y equals 8.2 times 10 8.25, take away 0.4 times 10.25 squared. So 8.2 times 10.25, take away 0.4 times 10.25 squared. And we get 42.025. And so that is the greatest height reached by the ball.